Hi, good day everyone. My name is Kavisha and today I'm going to present our group project assignment for instrumentation and control. Our group title is float switch sensor. Our group members are Amira Abdul Aziz, Nushara Farhana, Malavika and me, Kavisha. Okay, now I'm going to present about problem background. Why we use a float switch sensor uh, has our uh, pump to remove water and any storage. Okay, Calvert usually use diaphragma pump to remove water or any storage like rubbish like that. But it will only work when the water at the maximum level because diaphragma only sense when there's a water at a maximum level. So this will lead to problem when during summer day. Summer day the culvert will be in dry conditions. So the diaphragma will work but it won't remove any water or any storage. So it will still working but it won't function. So this will lead to failure. I mean the diaphragma pump will failure so fast in summer days because there's no water to it to remove. So we need someone to go and switch off the diaphragma pump. Then when there's water in the culvert, we need to switch it again. This will lead a lot of problem and a lot of manpower. So, but and plus the diaphragma will failure so far because it working but no water or any like things that can help it to remove. So it will failure so fast. To replace this diaphragma pump, you need a very high cost. So we suggest to use float switch sensor. Float switch sensor has our pump to remove water or any storage because this float switch sensor will automatically turn off during dry condition. So when have during like got water, it will on automatically. Okay, this is the problem background that we have see in this diaphragma pump. Okay, next. This is culvert filled with water and this is culvert without water. I have included pictures culvert filled with water and without water. That's all from me. My group members will continue next topic. Thank you.
Predictive maintenance planning. The best maintenance for mission critical equipment is preventing maintenance. Know what needs to be done is needs to be done, and there's no emergency scrambling. The necessary system downtime pays for itself in ongoing system reliability. The overview. Getting the best match between your equipment and your application is without a doubt the best preventative maintenance we can do. So as for we want to put a cover with a sensor on it, we need to find the best application for it and need to find the best maintenance to hold it for years. It works for motors, drives, and pumps, and it also works for sensors and switches too. Culvert pump switches are no exception. Yes, culvert pump does sound like one of the most straightforward application scenarios out there. There are three criteria to look at. The first one, set mode float switch functionality. Set mode float switch diagram. Most stem switches use a magnetic reed switch to open or close an electric circuit. Float switches are usually good to operate as normal open or normally closed switches. The float of a normally open switch rises with the liquid level towards the switch, and the permanent magnet attracts the switch contact, closing the electrical circuit. So that's the operating circuit explained. When the liquid and fluid descends, the reed switch contact will open again, de-energize the electrical circuit. This is a common configuration for high-level alarm. For a normally closed switch, it's just the opposite. When the fluid falls towards the reed switch, the switch contact will close the electrical circuit. So that's the function of ideal setup for a low-level alarm. The next criteria is environmental factor. The first environmental factor is dusty and dirty areas. The dusty and dirty areas will affect on the sensor bud. So, on the sensor bud, when it is dusty, there will be less accuracy on the result and on the detection of the water level. Next, the corrosive environment. When it is corrosive, it is the hazardous area. Corrosives come with hazardous area. So, as we know, usually sensor is made from metal. So when there's a metal and there's a water, it is a chance to burn out them. Also, it will rust. So it will need a maintenance for about a year once or maybe more to let the sensor work for a long time. So for the third criteria is physical factor. Physical factor is about the surrounding that we cannot change. So that's all from me. Thank you.
Good day everyone. My name is Malavika Lichwanan and I am from 2DMF. Now I am going to continue the presentation of my group, which is Instrumentation Control Design of Float Switch Sensor. First, let's see the transfer function. The magnetic float level switches work on the principle of reed switches activated by a permanent magnet inside the float. The reed switch is located inside the tube in a fixed position, and the movement of the float changes the location of the magnetic field, and the contacts of the reed switch are closed or open. The operation of the reed switch can be checked by using the continuity function of a multimeter. There are no serviceable components and any repairs should be returned to the manufacturer. The appropriate float should be selected to ensure that the float will work in the liquid's specific gravity. Your float should not have a specific gravity rating higher than or equal the liquid. And this is the image. Here is the reed switch, float, magnet, stem and stopper. All of this will be in the internet float here. Let's see the circuit diagram of float switch sensor. This is the Arduino circuit diagram of float switch sensor. Here, this is the reed switch. To make a circuit closed or complete circuit, float sensor use magnetic reed switch. The metal contact is normally open, but as we apply magnetic field or place a magnet bar near one metal end of the switch, it attracts the other end of metal, which makes the path for current to pass through. When the magnet moves far away the switches, the contacts demagnetize and will separate, switch breaking the circuit. And here is the reference image of reed switch which attract to the magnet. Next, this is the output. When we outfit sensor in an empty tank, the switch position is at bottom, but as water starts filling up, switch position rises up, which generates magnetic field for the reed switch. When level goes up, sensor make the circuit and series LED connected will turn on, and it will give the output of when level goes up, sensor make the circuit and series LED connected will turn on. And that's all for the instrumentation control design of float switch sensor. Thank you.
Hi, I'm Mira. I'm going to explain to you about the specification of the flow level sensor. Basically, flow level sensor are continuous level sensor featuring the magnetic flow that rises and falls as liquid levels change. So the function of the flow level sensor is to detect the level of the liquid within the tank. The material is made of stainless steel and the cable length is 30 cm, switching current is 1.5 ammeter, maximum contact resistance is 100 ohm, floating body size is 20 millimeter. So for the working principle is there are many kinds of level fluid sensor, but we choose this kind of fluid sensor. So all type of fluid sensor, liquid level sensor operating on the basic buoyancy principle. Submerge the liquid level sensor and will float on the liquid surface which partially submerged. Basically the level sensor won't be submerged fully, it will float on the surface of the water. Normally used for narrow levels such as high level alarm or low level alarm. Rising liquid level leaves the load, sliding the attraction sleeve up inside the enclosing tube and into the magnetic field to actuate the electrical or pneumatic switch. Subsequently, falling liquid level lowers the flow, drawing the attraction sleeve out of the magnetic field to deactivate the electrical or pneumatic switch. Fluid type level switches are generally able to handle high temperature applications and sometimes prove useful for close interface detection. Next, we are going to talk about the formula related for the level sensor. A hydrostatic pressure caused by the weight of the product is present at the bottom of the tank in the addition of atmospheric pressure. So hydrostatic pressure is equal to the atmospheric pressure plus the gravity plus the pressure of the length of the water and the level of the water. So this is the formula for the calculation. Next is the weight of the complete tank is measured depend on the level of the water. So this is the formula to identify the weight of the complete tank after there is water in the tank. So this is the formula. The weight is equal to the weight of the tank plus gravity plus area times area